welcome everybody. The talk is about mainly the developments in OpenTelemetry. What kind of new possibilities, opportunities it opened in front of us. I am Devrim. So basically, even the whole talk seems a very long path. Still, I will keep the sections mainly in kind of four sections. And that Pac-Man on the bottom, it's me. I started in 80s with Commodore 64, but later in the business life, I started with embedded programming, C++, then Java, again C++, and almost the first half of my career went with software development, basically, in telecommunications. And in this talk, the main goal I have is with visualizations, we can predict better. We can make better decisions. And visualizations were always my best friend in software development. And in the first era, when I started, it was mainly basically the software modeling was in place. I had to put a couple of disclaimers at this point. First of all, I'm working in Swisscom, but this talk is my individual perspective and does not reflect the views of or positions any kind of about my company. And the second one is I try to stay neutral. I'm not promoting any product or others. I'm just referencing them throughout the presentation as just references. And the third one is the AI. So I have given ChatGPT some of the texts to correct, or and especially after it arrived, it boosted my overall output. And the last one here is that in observability, everybody has some kind of consensus on metrics, and also logging is very essential. But my favorite is tracing and the metrics that are derived from traces. And also this talk is pretty much around these trace outcome metrics. So the first part I would be mentioning about the software modeling, the previous era from APMs. First of all, why software modeling became a hype around millennium 2000s. It was because internet was growing so fast and it needed scaling, and many other engineering sections do use modeling for building things and seeing things before they are there. Many projects were failing, so suddenly in 2000s, unified modeling language became pretty popular as a hype. So, but bottom line, internet's second wave needed scaling, and a lot of money was wasted. However, UML put a lot of nice artifacts and also non-useful artifacts together. Everyone, I guess, has seen this use case presentation. This is one of the visuals UML has introduced to us. And the second one I would mention is the sequence diagrams. This is my favorite diagram from UML hype because it's really useful and it has the time representation on it, but generally it's just represents one particular case scenario. The picture is from ForgeRock's access management documentation. It's still used, and it's very clear how you can implement it in an OIDC OpenID Connect. About UML, I will mention only one more. It's the class diagram. Pretty much I never used, but I still see in IntelliJ or other integrated development environments. It still exists, and this one is particularly from Mermaid.js. It's one of the many UML diagrams Mermaid.js diagramming as code supports. And about this era, the last thing I would be mentioning is use case maps. I don't know, anyone heard use case maps before in this room? Wow. I was not expecting someone to know, actually. But I'm coming from the telecommunications industry, so it's different from the current tech companies, and it has internet engineering task force, and a lot of standards are there. And aside from UML, UCM, use case maps, is actually a complementary type of presentation for complex systems. It embodies time representation in it. So chronologically, you can understand where it starts, where it ends, where it visits. So it's more like a pet-centric approach. I used it a lot, and I'm still using it. There are not much tools supporting it. But this era, at some point, finished. And in my perspective, this is a personal talk. The three things happened around 2008, 2009. One of them was the Linux. Really, the operating systems, Sun, HP UX, those big invoices suddenly changed to an Linux, and actually it did work very well. And it had a tremendous effect on our industry. The second thing, DevOps, it was SDLC, application lifecycle management, whatever you would be putting there. But for me, it was just a Jira task ID that's used inside the commit message, which enabled, with the continuous integration, we were able to understand really this code is running on this environment. And for me, in that sense, it was very small sparkle, but it changed the industry. And the third one is iPhone. I was working in research and development department of evaluated service telecommunications. When I first touched it, I understood that there is no value-added services anymore in any telecommunications company. It changed the way we live, way we interact. It was a big change. And I was actually very lucky that at that period, I was able to switch lanes. I switched to technical consultancy. I stopped telecommunications research and development stuff. And in around 2003, I had a very small visit with the application performance management product by a Israeli company, Mercury. It was load runner. I guess a lot of people knows what load runner is, but also it had an APM back then, which I was very lucky that I happened to start consulting with APM products. During the previous software era for me, we tried a lot of performance engineering stuff, and I do consider, in a sense, even in that era, I was a performance engineer. It's kind of plateau. I had almost 15 different customers, including banks, streaming services, small customers, retail, and at the end, I would, as a summary, would put, unfortunately, the Gartner's conceptual model that it really reflects what APM was in that sense. Now we are seeing this transformation from APM. Of course, logs and many other stuff is added. Now the name became more inclusive with observability naming. However, these 5 pillars back then was really describing the value of APM products. And that's what I would be searching in the visualization. This is from one of my very first implementation, a screenshot from a core banking application from the Mercury HP Diagnostics later. It happened to be the product name. I find it from archives. If you take a look at it, it involves discovery, monitoring, display of application components, and it's really elegant so that you can directly see where almost the problem input, output. This visualization was so powerful, and it served a lot of customers in many ways. In a lot of instances that I witnessed, forensic, sometimes just directly finding it, whether the problem is DB or network or request incoming. It was really powerful. And the second one, I skipped the first one, by the way, the end user experience. Yesterday there was a Carly's session. It's more about probing synthetic testing, load testing, and user experience in that sense. When moving to observability, that part kind of forgotten as a pillar. So in the business transaction, the difference between the runtime application architecture is that it looks just, now we call it trace, one transaction from end to end. The runtime application architecture pillar looks at the system overall. It both serves great for different times. And the third one is the deep dive component, as Gartner says. Sometimes it's called call graph, transaction flow. Nowadays it's the trace presentation. And you can see that this is also a screenshot from a customer on a Java server. The blue part is actually happening on another server, on another endpoint. And you can see which one gets the most latency there, so you can find the bug. It's a flame graph representation. There are 3 representations, but the most I like is the flame graph in general. And the second one here is the Jaeger part. And this is where tracing and APM use same methodology. And this is the core essence of the whole picture, actually. So this one's from last year, from Grafana in that sense, Grafana site, you would see that the previous deep dive component tracing as the deep dive, this trace itself. And the node graph over it on Grafana is the business transaction that is derived the data, that those connections are extracted from the trace itself. And also on the left-hand side, this is the service graph dashboard. It's also using, first the traces are converted to span metrics, service graph processor converts it into service graph metrics, and it's formed. So what I would like to point out on this one especially is that actually the other visualizations, everything is dependent on the traces. Before, other products were naming it with different stuff. For example, the product I was consulting, it was HB coloring on the header. Another product was doing it in a different way. But that's the intersection of distributed tracing and the APMs, what they were doing before. It was good, and it was efficient, but there was the difference between the tech giants and the enterprise market. So tech giants were using distributed tracing, open tracing, open census, because they have many developers. They are almost producing their own software. It was not applicable to the, for example, a bank that purchases 400 different applications from 100 different vendors and stuff. And on APM market, auto instrumentation was in place. On distributed tracing part, mainly manual instrumentation. Developers were adding some lines to their code together. And again, before 2019, for me, another thing happened. It was two things. One is the COVID itself, definitely. It accelerated technology a lot, in a sense. And also the other one was suddenly everyone, 10 years, everyone was talking cloud, but suddenly everyone was rushing to cloud and Kubernetes. So that triggered, in a sense, a big change. At this point, before I go to the prototypes and different visuals, I would like to put the context first. There is the APM, and also there was the software modeling. On software modeling side, the tools evolved. So architecture as code, static code analysis, diagramming as code. Many things were moving forward. When you pass towards APM and distributed tracing side, there are many buzzwords. Very similar to software modeling, but you can see application map, application dependency map, service topology, service map, system architecture, network map, very close. But when we get out of the IT part, also there is another world using the very same buzzwords. And you come across the graph theory in university, in computer science, then the network graphs, and suddenly you start to realize that actually it's not just our part, same words are used and same problems exist in network side, like the social networks, network of networks, protein networks, neural networks. So it is not just these visualizations our problem. It also exists in other places. And especially if you go towards, there is Barabasi, which has the kind of introduced the term network science. That's a physical output of a, on the right-hand side is the brain and the neurons from Connectome exhibition they had in 2019. And they're also calling it data art, data sculptures. I won't go from here what is art, but the difference when you come close back to our lines, it becomes the together used technologies, art, data visualization becomes very obvious at that point. However, the main difference is that physical networks, how we visualize them, but on the other hand, like ours, virtual networks, software networks are different. In physical networks, no two connections, it's physical, can go between it, but we represent in software modeling, a lot of things can go inside like ghosts from each other. So the context I'm giving here is that what we are actually dealing with is dynamic temporal graph networks. It's our data there. And the thing about it is the difference between software modeling and APM distributed tracing part, the switch between that is mainly you can consider software modeling more like a map. Even no cars comes around, maps still resides there. Even if you shut down the system, the model that you have drawn exists on a paper, on a document, but the information collected by APM's distributed tracing is temporal. Temporal means it's related with time. If there is no action, there is no data there. So, and in that sense, it's bottom line, it's also working in CPUs and machines, so it has space, location. It's a spatial data, but again, the most good example I can give here is once Waze and other traffic applications are doing it. They are crowdsourcing your location when you use that application. And back to back, sometimes they introduce new roads without mapping. So it's kind of interchangeable. You can derive maps from the temporal data, but it's hard. I have given the context so that to look at what we are dealing with. After this cloud rush and COVID, somehow APM world and distributed tracing world magically got together. The first thing was OpenSense and OpenTracing got together. And also some APMs supported it. And I have seen the first ever free open source Java agent in end of 2019 from Inspect IT, and the OpenTelemetry Java agent was the first one I have used. And with that, what I could, if you can remember the sequence chart from UML, the right-hand side is a data I collected from OpenTelemetry, and this one is produced automatically to check the compliance visually if it does our network what it does. So in security terms, by putting OpenTelemetry agents, I was able to extract these sequence diagrams and checked over 100 different possible scenarios if they are compliant with OIDC, SAML flows that are defined on documents as sequence charts. What I would say that the OpenTelemetry FTL it was faster than light. After that sequence diagram, just in 2.5 years, These numbers are 1 year old. No new technology was there. It was more like a consensus over a goal. So the community and the vendors magically done tremendous job just in 2.5 years. Any APM consultant would know that some APMs are better in .NET, some are better in Java, but none supports 11 languages, 12 languages, or this much. So for me, the biggest part here is the coverage OpenTelemetry has achieved in terms of different technologies. And this opened different innovation paths, like we have seen that ServiceNow has merged with other. Arcum.io was OpenTelemetry asset management system was purchased by, I guess, Honeycomb. On the testing side, trace-based testing was there. It opened different startups. Aspect.io was acquired by Smart here, I guess, the Zephyr Jira plugin. And the others are there. And also, really shifting left was happening, going towards developer. OpenTelemetry collector was really a game changer in that sense. For me, the most clever architectural pieces there. But real shift left, like Digma AI, you see a line of code on your IntelliJ, and it says this line has been called 1,500 times in front of the developer. So this is the shift left. Otherwise, no developers were connecting to observability systems and searching for other stuff. And also some other remarkable ones I just mentioned there. To keep it short, I would just leave it on the slide. I was kind of excited by that time, but when I saw this image, this visual by Kyson Lee from Google in a presentation beyond distributed tracing, I was really amazed. This is really beautiful in a sense that and in an outage in YouTube, they were able to spot where the problem was very quickly, and it's done via enabling by OpenTelemetry, which was very inspirational to me as well, so that we don't have to stick with just the traditional visuals, business transaction and the other. The APM world was giving those two for a decade or more, but we can have more. And we can reduce time to resolve. A lot of things exist as opportunity here. At this point, I will mention very brief about Yuri's research, I would say. The link would be available when we publish the presentations. However, there are much more metaphors she has put, and she's still doing it. This one particularly, it's a kind of research that you are putting two system admins in front of the two test groups, to say so, and giving different screens to find out the problem. And for example, the ones that are looking something like this is more successful than the others. So the visuals you present and how you present them is really changing the game. We are in London, so also it's a very root of one specific type of simplification. and that's the London Tube map, very important one. It's a very important for visualizing humans to grasp an information very quickly, but on the other hand, it omits a lot of stuff like geography and so forth. The upper one is from 2022 for OpenTelemetry. Especially, it is useful for data pipelines, pipeline representations. Where does it pass? Which stops does it put? The other one is from during KubeCon. I was inspired. One of the OpenTelemetry sessions is similar. So, bottom line, metaphors can be very helpful in operations departments for success. And now we are here in the age of AI. I will quickly go through what I would be doing. This one is again Carlos Aguni. He has great intuition, and this was what I was prototyping. It's when you click any service, it shows as an operation at the very end where it lands differently. So this is achievable actually formally by OpenTelemetry. And I kind of tried to prototype it. First, I started with diagramming as code programs. This is OpenTelemetry demo application. All visuals you would be seeing is OpenTelemetry from the OpenTelemetry demo application. Thanks to ChatGPT, in a day, I was able to get these from Prometheus metrics that was provided with trace data as spam metrics and service graph metrics. Later, I, in a second iteration, achieved the right-hand side, but this was pretty the end of the diagramming as code. So in the AVS session yesterday about the CDK, that they said that declarative is okay, fancy, but you reach the end very quickly. I guess that's the same with the diagramming as code products at the moment. You reach the limits very quickly. At this point, I checked the visual library options. First of all, I'm looking for open source ones. And luckily, it's not just our problem. Biology, protein networks, crime networks, social, everyone is looking for data visualization. And options are actually limited. The commercial best options I have seen was Cambridge Intelligence and the Y-Works from Europe. That one's main essence for me in system visualization, observability visualization, is that you can collapse, open, zoom in, zoom out. These navigations are very powerful on that one. And the other one is Y-Works. It's not so different. It's also very powerful, but they also support octilinear paths presentations like trains, like metros, transit maps. That's also important. However, on the open source side, I've concluded there are two options at this point in time available. I started with D3.js, but its learning curve is a little bit harder. Also, for network maps, it is a little bit, you should do more coding on that one. So I started to use Cytoscape, which I have seen that many APM products were actually using Cytoscape in the backend. It's mainly a protein network analyzing data visualization software. My search was mainly what I can put inside Grafana, what I can put inside Kibana, whatever. Web support was very important. So Cytoscape has a great JS library there, and it was very easy to use. This graph, I was able to get it within 24 hours. With D3JS, I spent different nights after my normal working hours. And I was slowly going. But with Cytoscape, I put the OpenTelemetry application. I had this graph, and when I click, it was opening. When I close, so you can make it bigger, which then I started to put aesthetics, colors, and stuff. At this point, up to a point, you would be only seeing the graphs that are generated by Prometheus metrics, still not the trace directly themselves. So this is, again, OpenTelemetry demo application, same graph. I'm putting the previous ones on the left hand, would be going to stack up there. So this one, a couple of days when playing with its sizes, it changed to this one. You can think that every container here itself is an operation, an endpoint, either receiving or sending something. Each one is span, and these are the status codes on those traces. In a sense, it's like a microscope. You have the glasses, and you put another glass on it, and you see the microorganism, microservice under a microscope. So it's semantically fitted its own context as well. I have some videos I have put on YouTube during the time I was doing it, and it kind of looks like alive. This is the starting of OpenTelemetry applications. Some of the components are intentionally closed. In a chaos engineering perspective, pretty much every time you open in Cytoscape, this is refreshing every 10 seconds, 15 seconds, you see same stuff happening, like a cell growing up. So it's kind of, you can compare an image that's been taken in the first minute of the start. And if you see the same image later, you would understand that these three services are closed. Then you see those parts. And at this point, this is where I used also the trace data itself. However, to understand this one, the red ones, the upper part is the load generator, is sending something, and the problem is here front end, it's bleeding, in a sense. And those two are connected. When we try to get a trace, you would see that the load generator's HTTP GET actually falls into that part. The middle part, for example, 2.7 is the number of requests sitting there. Their sizes are accordingly. And these are very programmable in Cytoscape. And pretty much the last visual I have prototype where I selected here. You can check the others there. This one's difference is that actually we represent when trace goes somewhere, we forgot the time. But until its response arrives to the load generator back after doing something, it's not something just one-way arrow. It travels and backs. This representation has time embedded in it, and it's more use case map style. And after that, I stopped my prototypes. I started back to aesthetics, decluttering. So some Wes Anderson movie colors I tried to put, and I also put the error bars like a gouge inside. So these are just, again, to show you what's possible. We need better visuals in that sense. I'm just putting my blocks, pretty much my GitHub repo and the visuals, my footsteps are available there. If you are interested, please do not hesitate to contact me. And the last one I would show is actually, I never had the chance to meet them. It's just 1.5 minutes long. Yes, it's here. And this is not mine. This is from a university. I never met them, but you can see how. Oh, yeah. Thank you for reminding that. This is someone else's dream that they visualized like this. Similar studies you can find from Yuri's website, and so we can have better visuals.
Thanks for the talk. I was just wondering, when you showed us Grafana, the Grafana Jaeger
Yes.
view, you also had a network view.
Yes, service graph processor on OpenTelemetry collector. My voice is coming, right? Yeah.
So
Service graph processor.
service graph processor.
Yeah.
Okay, cool. I just we didn't have that, and I thought that was very cool.
I'm hoping we would be having a topology processor at some point in future, so that it's not just service to service, any microservice, any operation to operation would be available. What's missing for me is that we have timestamp nodes, but not the edges. We need an edge DB, relation DB, and that information needs to be stored somewhere to form those stuff. At the moment, they are labels on Prometheus metrics from like source target.
And it's like a plugin.
OpenTelemetry collector, there's a processor. Actually, their names is at the moment connector.
Yeah.
Service graph connector and spam metrics connector. Any other questions?
Does anybody have any questions? Nobody. So thank you.